That makes sense.
I have to do my blood work done. I didn't
They're
find
probably
it.
two that are in like 14 seconds. It's two really.
That's, I would like for you to go through them, see what they do, but I'm not gonna require this to be. I think it'll be
Yeah.
back at five.
And then it's so, it's like, come back, so you're all just like, yeah, this is something that you need to. There's no, really. Certainly, I like. I have some. The one was it was filtered one because it's like, it's because you were thinking you would go over there, you're like, oh, like, it's in a lot. Like, I'll have next. The actions. So they do a lot of. Okay, they don't.
Next week is EOC week again, and the schedule is all going to be thrown off. At the beginning of the week, if you look up to my website right before the 25th, I have the EOC week bell schedule. I'll send this link out tomorrow afternoon as well. So that you guys can, I think for all of you, it's going to be a late start date for each of the days. I will go over more details about your AP exam. I have a handout with all the details about the AP exam. But this is what the AP exam will look like. You're going to start off with the multiple choice test portion, and on the AP exam, the first part is a non-calculator portion, a multiple choice section, and that's 30 multiple choice questions. You have 60 minutes, so you got to move pretty quick. About 2 minutes per problem. And then after that, they'll take that portion up. They'll give you a second packet, and that second packet will be the graphing calculator portion. And that's 15 multiple choice questions in 45 minutes. And you're going to feel like you have way too much time. But I just, it actually is a little bit better than before, but still, you're not going to need all that 45 minutes to do 15 multiple choice. But that's calculator active. But keep in mind that not every question is meant to be done with the calculator. So, it's just calculator active. You have to decide whether the calculator is appropriate for that problem or not. But some problems are meant to be solved without a calculator, or the calculator doesn't really help for some of the problems. So just keep that in mind. After that, you'll have about 10-15-minute break, and then you'll come back and you'll do your FRQs. First, you're going to start off with 2 FRQs. Well, they're going to give you a packet, but I think problems 3 through 6 will be sealed, and then you're going to be working on problems 1 and 2. So you'll be working on problems 1 and 2 with a calculator, and you have 30 minutes. Okay. Now, after 30 minutes is up, you got to put the calculator away, and then you'll unseal 3 through 6, and you can start working on 3 through 6. And you have 60 minutes to go through 3 through 6. But you can go back and work on 1 and 2 still. You just don't have the luxury of the calculator anymore. So just keep that in mind, that you can work through, you can divide your time however way you want to between the 6 problems. But if you're running out of time within that first 30 minutes, try to do the problems that have the calculator required. And then once they take the calculator, once you remove the calculator, you can still go back and tidy up those problems from 1 and 2 if you need to. I'll go over a lot more details and tips and things like that. But any questions right now? I can give you a big overview so you know what to expect on the AP exam in terms of format. Technically, the 36 Pro is not on the approved calculator list for the AP exam, but I think students still bring it, and unless, someone tells you to put it away, some students still use it. So, but in the past, they would allow it, or in the past, it was on the approved list, but then for some reason, they took it off the approved list. So just keep that in mind that, if a proctor tells you to put away 36 Pro, technically they have the right to do that. But, I see some students, they would bring 36 Pro and a graphing calculator, just so, sometimes one feature is easier to do on one than the other. You can have that as well. You can have 2 calculators if you want to do that. But, the safest bet is just have a graphing calculator, and then that will handle everything you need to do. And also with the 36 Pro, it can't do the graphing features as well, and it's a little cumbersome with the table of values. So graphing calculator, I think is the best way to go on the AP exam. Okay. I have the list of details about your AP test for next week. Okay, and I want to leave this on the board so that hopefully all your questions will be answered. So on Monday, again, 8 multiple choice questions. You have 30 minutes. I will have a morning help session, but I know that there's such a big gap that most of you guys still be at home. So I'll definitely send out a Teams link if you want to join on that Teams link on that Teams call for me to go through the morning review. Okay. And then on Thursday, we'll do the 8 multiple choice questions for second semester topics, integral topics. Also 8 multiple choice questions, 30 minutes. I don't know if I'll be able to do a morning help session on Thursday because I have to proctor the bio EOC. So if that's the case, I may either I may do a help session Wednesday morning instead. Wednesday morning. Again, I'll send out Teams like most people will still be at home. So join on Teams. Okay, so the pages for first semester topics, pages 1 through 8, and then 13 through 18. 13 through 18 includes some miscellaneous topics as well as the morning review that I'll be using on the day of the morning of the test. And then Thursday's test topics, page 9 through 12, and then page 19 through 22. Okay, again, calculators are allowed. No formula sheet provided, so encourage you guys to go to the formula sheet attached to your packet and start looking through those formulas and begin committing them to memory. I guess the good thing is that you don't have to memorize them all at once. You can just focus on the first semester topics, formulas for Monday, and then the second semester formulas for Thursday. I'm going to grade a multiple choice test as a free response, meaning that I am going to look to give you partial credit, especially if you're answer the question incorrectly. I'm still going to look for partial credit, especially if you're showing correct work. But that also means that I will be asking you to show me your work. Even if you get the correct answer, if I don't see the appropriate work, you're not going to get full credit. Okay. And then finally, if you go through the whole packet and you still want additional review, I would just ask you to start packet 6. This packet 6 is just a collection of multiple choice tests from College Board. So you can get additional practice there and start knocking out problems for packet 6. So you kind of do 2 things at once. If you start packet 6 early, you're also kind of reviewing for next week's tests. Okay, any questions about the schedule for next week? Okay. All right. Let's go to page 4. I do want to highlight a few things here. Let me just point out some of the steps from the keys, since you guys have all worked through them. And yeah, some of these require calculators, so hopefully my explanation on the key is sufficient where if you didn't quite know how to answer the problem, the key helped you figure out how to set that up. Okay, page 4. Yeah, this is an important concept here for number 4. Whenever you see a piecewise function and they tell you that the problem is differentiable, they're kind of giving you a hint to do two things. The two things is that if you see the word differentiable, it's really two things. It's really continuous and differentiable. So if it's a smooth curve, you know that it's already telling you indirectly that it's also continuous. So if a graph is continuous, you know that the two piecewise functions, they must share the same y value. But if the function is differentiable as well, you know that these two branches are not only going to connect at the same point, they're also going to connect in a way where it's going to be a smooth curve. So they will also share the same slope at their points. So the strategy for this problem is that you set the equations equal to each other, you set their derivatives equal to each other, and then from there, you're just trying to solve for C or D using substitution. And then you're going to treat C and D like constants. Right? So that's why Cx plus D's derivative is C, and then D goes away to 0. And then x squared minus 2c becomes 2x minus c. So pretend C and D are just like 3s and 4s, or just constants, and just treat them like constants. Okay. So circle number 14, that's a popular type of problem to show up on the AP exam. Average rate of change. Another way of saying average rate of change is average slope between 2 points. So it's not saying instantaneous rate of change. If it was, then you would have to involve the derivative. But here you just find ordered pairs and just find the slope. Tangent to the graph. So you know that the slope is whatever you can gather between the two ordered pairs, and so if it's tangent, then it's going to share the same slope as what you between these 2 points. Same idea. 17, another calculator question where you have to set f prime equal to 1, and then bring everything over to one side, and then you graph your polynomial and look to see where it crosses the x-axis, because that's going to be your x-intercept. And if you have your x-intercept, find that ordered pair, and then from there you can create your point slope form. Okay, implicit differentiation. So let me do a quick review of implicit. Implicit is where you find the derivative of every variable, but we take special care of the y variable. So anytime you come across y variable, once you activate its derivative, you got to apply the dy dx. Right? X's are treated the same way, but you got to treat y a little differently because y is the dependent variable. So it says find dy dx. So to find dy dx from 3x squared minus 4xy, I have to go through a power rule here, but 4xy, there's a sneaky product rule hiding here, right? So 4x times y, we can't just say 4 times dy dx. Those are two separate variables there. I got to go through product rule. So f prime g plus f g prime. When we get to g prime, that y's derivative becomes dy dx. And then once you solve for dy dx, you can plug in your x and your y. If you don't know what your y value is, you can always insert that x back into your original equation to get your y value, and then insert all that into your derivative, and you can solve for dy dx. Okay, what is the slope of the tangent? At 0.32, we can find the derivative using implicit. Anytime you see y, you got to do dy dx. And again, there's a product rule hiding here. We got to go through product rule as well. Once you have that, plug in your ordered pair, and then you can get to your slope value. Okay. Any other questions, page 1 through 4? Okay, let's continue through page 5. We're starting off with related rates. Okay, so related rates is where every variable gets the time treatment. Every variable gets impacted by time. So there's a d over dt for every variable in the problem. Okay, so number one, it says the rate, number one on page 5, the radius of a circle is decreasing at a constant rate of 0.1 centimeters per second. In terms of the circumference, what is the rate of change of the area of the circle in square centimeters per second? So we have two equations that we're working with here. We got the area of a circle, and then we have circumference of a circle. So area is pi r squared. Circumference is 2 pi r. And for some reason, if you forget what the circumference formula is, you can just take the derivative of your area and that'll take you to your circumference. A is pi r squared, circumference is just 2 pi r. So that's a nice connection there. Okay, so I'm just going to go ahead and find the derivative for A because I know I'm going to need it. So A becomes dA dt, right? Every variable gets impacted by time. Pi r squared becomes pi stays, r squared becomes what? 2r and then dr dt, right? So every time, whenever time is involved in the problem, it's always going to have an impact on all your variables. Okay, the radius of a circle is decreasing at a constant rate of 0.1 centimeters per second. What can we assign that value to be? dr dt, anything special with that? Positive or negative? Negative, that's decreasing, right? Okay. In terms of the circumference, what is the rate of change of the area of the circle? Okay, what are we looking for? Okay, so we'll go ahead and plug as much information in as we can. So dA dt is equal to pi times 2r times dr dt, which is negative 0.1. Okay, but it says in terms of circumference, so I want to be able to represent my answer using c. What can I do here? 2 pi r is the same thing as what? C. So what if I just replace that in terms of C? That's what they want, right? They want the answer involving circumference variable. So dA dt is just C times negative 0.1 or negative 0.1 times C. Okay, number 2, the radius of a circle is increasing. So we know that's talking about dr dt. It's going to be positive. At a certain instant, the rate of increase of the area of the circle is numerically equal to twice the rate of increase in the circumference. What is the radius of the circle at that instant? Okay, so again, we're playing with the same two equations, A and C. Let's go ahead and just list them out and find their derivatives and see where that leads us. All right, so I just listed out all the derivatives here. Okay, it says the rate, okay, at a certain instance, the rate of increase in the area of a circle. So rate of increase in the area of a circle, what is that referring to? Rate of increase of the area of the circle, the ADT. Okay, so the ADT, it says that the ADT is numerically equal to twice the rate of increase in the circumference. So dAdt is equal to what? 2 dCdt, yeah. Okay, so or at least they're able to get those words into some sort of formula. What is the radius of the circle at that instant? Okay, so we know that dAdt is equal to 2 times dCdt, and we're looking for the radius. Well, I can make some substitutions, right? I know that dAdt is twice dCdt. And then I know that dCdt is also 2 pi dr dt. So I'm just going to continue to make substitutions in a way that will help me cancel out some variables. So I know that dCdt is 2 pi dr dt. So I could basically take this, right? This is going to be a clean substitution for dA dt. And if I can set these two equal to each other, I can cancel out the dr dt and I can solve for r, right? So I'm just kind of a little bit of a puzzle here to try to figure out how to get everything to line up. So if I multiply this through, I get 4 pi dr dt. Which is equal to 2 pi r dr dt. And then we have enough variables canceling out where we can just isolate the one variable we're looking for, which is radius. So the dr dt cleans up nicely, which is left with 4 pi equals 2 pi r. R is the variable I'm looking for. To solve for r, divide both sides by 2 pi. So r is simply equal to what? Good. Okay, number 3, if the base of a triangle is increasing at a rate of 3 inches per minute, while its height is decreasing at a rate of 3 inches per minute, which of the following must be true about the area of the triangle? Okay, so we have the area of a triangle being 1/2 base times height. We have all these rates that are showing up. So why don't we just go ahead and find the derivative so we can make some substitutions and kind of see a little bit more clearly what's going on. If I do want to find the derivative, dA dt, what has to be involved here? Product rule. I can't just say dA dt equals 1/2 dB dt dH dt. It feels easier, but that multiplication forces us to have to go through product rule. F prime g plus f g prime. What's f prime for 1/2 b? Good, 1/2 dB dt. G function, no changes. F function, no changes. And what's g prime? H becomes dH dt. Okay, so let's make some substitutions here. The base of the triangle is increasing at a rate of 3 inches per minute. What's that referring to? dB dt is positive 3, okay. While the height is decreasing at a rate of 3 inches per minute. That's what? dH dt. dH dt is -3. Okay, let's make those substitutions and see if we can get some more clarity as to which of these options we can claim to be true. So replace dB dt with 3. So I get 3/2 h. And then if I put -3 in for dH dt, I'm going to get -3/2 b. So this is as far as I can go. And now let's look at our options here and see which one has to be true. Okay, it says that A is always increasing. Well, in order for A to always be increasing, that means dA dt is always positive. Can we guarantee dA dt is always positive? Right, not if B is larger than H, right? Because then we're going to get a negative value. So we know this is out. A is always decreasing. Not necessarily, right? If h is greater, then my d dt is going to be positive, so that's going to go against that statement. A is decreasing only when b is less than h. So when b is less than h, this is going to be a positive or negative value. Positive, so we know a is not going to be decreasing, but increasing, so that's not correct. A is decreasing only when b is greater than h. So if b is greater than h, this number is always going to be what? Positive or negative? Negative, and so a is decreasing. This is true, right? So this is our answer. Our answer choice is D. A remains constant. That just means that d dt is always a numeric value that's never changing. We know that's not true, right? Depends on what the h and b are. So it's just got to be C. All right, number 4, the radius of a sphere is decreasing at a rate of 2 centimeters per second at the instant when the radius of the sphere is 3 centimeters. What is the rate of change in square centimeters per second of the surface area of the sphere? The surface area is S equals 4 pi r squared. So, okay, so that's our equation that we can begin working with. I know I got involved with derivative, so I'm going to just go ahead and build my derivative out so I can see all my variables in play. S becomes ds dt, 4 pi r squared becomes 8 pi r dr dt. Okay, let's list out some information here. The radius of a sphere is decreasing at a rate of 2 centimeters per second. What variable is that? Dr dt, and anything special with that? Negative. At the instant when the radius of the sphere is 3 centimeters, just r, okay. What is the rate of change in square centimeters per second of the surface area of the sphere? What are we looking for? ds dt, okay. So everything, this is pretty straightforward, right? Everything is in front of us. We just have to plug in and solve for ds dt. Okay, replace r with 3, replace dr dt with -2, and the only variable left standing is ds dt. Now, I know it's not indicating it here, but what is going to be the units of measure for ds dt? Okay, so think about surface area. What's the unit for surface area? Yeah, square centimeters, and then the time component is seconds, so it's per second. With related rates, similar triangles show up for cones. And I don't have a cone problem here, but we know it's tedious with the whole, having to set up your proportions and having to solve for either r or h and then cleaning all that up. There's another instance that commonly shows up where a similar triangle is used, and that is with these shadow problems. Okay, and these shadow problems are they're not hard. They're actually a lot easier than the cone problems. Still also use similar triangles, but it's very specific, right? So the steps that you take is very specific to this problem. So I want to make sure I go through this with you. A person whose height is 6 feet is walking away from the base of a street light along a straight path at a rate of 4 feet per second. If the height of the street light is 15 feet, what is the rate at which the person's shadow is lengthening? So I can create a triangle within a triangle. Basically, that light is going to create the shadow on the ground. And as the person is walking towards or away from the lamppost, that shadow length is increasing or decreasing. Now, we see a triangle within a triangle here, so we got a triangle formed here with a person, and we also have a triangle formed here with a lamppost. Right. Now, the way that I organize my variables here, the person's height and the lamppost, those are set, those are constants. So we have 6. Let me redraw the triangle so we can just have everything to be a nice diagram here. So we have 6, and we have the street light, which is 15 feet. Now, I like to go through this format here. I call this X, and I call this Y. Now, first thing is you want to set up your proportions. And I say this, I say the height of the small triangle is to the height of the large triangle, as the base of the small triangle is to the base of the large triangle. So what's the base of the small triangle? Just Y, right? Not X. I know a lot of students want to do X because X comes first in terms of alphabetical order, but X doesn't represent any full base, right? It's the Y that's the base of the small triangle. And what's the base of the large triangle? X plus Y. So that's the hard part. If you can get this part set up, then everything else feels a lot easier. Okay, so let's go ahead and cross multiply to get everything, all the denominators to go away. And then once you cross multiply, then we can find the derivative. And then we can list out what we're looking for. Okay, distribute the 6 through the X plus Y. I get 6X plus 6Y is equal to 15Y. Combine like terms. 15Y minus 6Y is 9Y. So 6X equals 9Y. Now we find the derivative. The derivative is going to be very simplistic because it's just a linear equation here. 6X becomes what? Good, dx dt. Every variable gets impacted by time. We're still doing related rates here. 9Y becomes 9 dy dt. Now, the way that I define these variables is very specific in terms of what they mean. So let me write them out for you here. dx dt is the rate of change of the person walking. dy dt is the rate of change of the shadow length. And if I add the two rates together, dx dt plus dy dt, you guys remember rate of change of the what? At the tip of the shadow. And so those are all the components. The equation is easy. You just have to know what each of them represent. Okay. So it says, what is the rate at which the person's shadow is lengthening? So ultimately, we're looking for which variable? Yeah, we're looking for dy dt. What can we put in for dx dt? How do we know whether the dx dt should be positive or negative? Okay, so if he's walking away from the lamppost, what's happening to that x? It's getting larger, right? So we should get a positive rate. If the person is walking towards the lamppost, x is getting smaller, so dx dt should be negative. So in this case, though dx dt is positive because he's walking away. So plug 4 in for dx dt, and now then we can just solve for dy dt. So 24 divided by 9 is dy dt. And I can reduce that to be 8/3, which is equivalent to 2.67. Okay, number 6, now we're looking at derivative graphs here. It says the graph of the function f is shown below. Which of the following could be the graph of f prime or the derivative of f? So we know the derivative of f is showing the slope of every point here. So I'm just going to give myself some random numbers to target here since the numbers are showing up here. I'm going to call this 1, -1. I'm going to call this 1 here. Just to kind of have some numbers to work with. Okay, if I want to create a slope sine line for this graph, what are my critical points going to be? Remember, this is the original graph here. -1 and 1, right? So those are my peaks and valleys. Those are my, this is the original graph, not the derivative graph. Okay, what's happening to the slope between the left of -1? Positive or negative? Positive. And then between -1 and 1, negative, and then to the right of 1, positives, right? So positive, the negative, positive. Now, second derivative sine line. Can you tell, if you have to guess, where is the point of inflection going to be? 0, right? That curvature changes concave down to concave up. So at 0, point of inflection, and then to the left, concave down, to the right, concave up. So even without looking at my answer choice, I'm going to just try to create a derivative graph with these features. So I know a derivative graph is going to look like this, right? Anything above the x-axis is positive slope. Anything below the x-axis is negative slope. Anything on the x-axis is slope 0. Okay. So what can I put onto my x-intercept as x-intercepts? -1 and 1. So I'm going to go ahead and plot those points. Where do I want the graph to live to the left of -1? Above, right? And it's got to connect to this point, so I got to have it fall. Between -1 and 1, I want the graph to be where? Below, so it's got to come down, loop back up, because I have a point that has to reach. And then to the right of 1, my graph is going to be above. Okay. Now, I know for my second derivative graph, concave down is going to be where my derivative graph is going to be what? Negative slope, right? And that matches with what I see. It's kind of already, I'm able to create that even without getting this in front of me here. So negative slope on the first derivative graph indicates concave down. Anywhere there's a peak and valley is a point of inflection, and anything to the right of my graph is positive slope. So that does correspond to concave up. So my graph should look like this. So option choice B. Okay, curve sketching here. Curve sketching topics here. Let f be the function with a derivative f prime. Which of the following intervals is the graph decreasing? Okay, so remember, this is the f prime, not the f of x, is f prime. So what I can do is if I can just find my critical points here and then test each interval, I should be able to know where my critical points will live. So if I want to find critical points on the f prime, I'm going to set the numerator and denominator equal to 0. But right now, that denominator is not very clear, right? It's two separate fractions. So if I can get it to be one fraction, that would be a lot cleaner for me to interpret. So I'm going to try to merge it into one fraction. But to do that, I need common denominators. What's my common denominator? X. Right, both can go into X. So the second one has no changes, so my numerator will stay. My first is I need to balance the denominator with an X, so I need to multiply the top by X, so X cubed. So critical points on a graph comes from both the numerator and denominator. So I need to set both equal to 0 separately, and that way I can find all the critical points that needs to live on my sign line. If I can just create my sign line, I should be able to help identify all the intervals that I'm looking for. So if I set the denominator equal to 0, I get x equals 0. If I set the numerator equal to 0, I get x cubed equals 2. So therefore, x equals the cube root of 2. So onto my slope sign line, I'm going to place 0 and cube root of 2. I'm just going to test each interval with my derivative. Okay, here I can test -1. Here I'll test 1, and anything greater than 2 is really, yeah, 2 is greater than cube root of 2. Right? So insert -1 in for x. I get -1 minus 2. It's negative over a negative. That's positive. So this interval, my graph is displaying a positive slope. Between 0 and cube root of 2, that's 1 minus 2 over 1. Negative over positive is negative. If I plug 2 in, I get 8 minus 2 is 6. 6 over 2 is positive. So my interval is decreasing from 0 to cube root of 2. All right, number 8. The graph of a twice differentiable function is shown. Which of the following is true? It's asking what is the order of values between f of 1, f prime of 1, and f double prime of 1. Okay, so without even looking at the list of options here, let's just see if we can estimate what we think these values are. Okay, let's start with the easy one here. What's f of 1? 0. What's f prime of 1? We don't know the value, but we can kind of guess, right? F prime of 1, what's the slope at 1? Or let me narrow it down. Let me make it even more broader. Is it positive, 0, or negative? This is positive slope, right? You see at 1, the graph is rising, so we know it's positive. Or in other words, it's greater than 0. Okay. What's f double prime of 1? Because this is part of a what? Concave down. So concave down is negative, right? So we know this is negative. So therefore less than 0. So if I want to put this in order, I know negative, this will be the smallest, followed by the 0, followed by the positive. Okay, I'm going to have you guys finish pages 7 and 8 for tomorrow, and I'll check pages 5 through 8 tomorrow. But I'll also go through those pages tomorrow just to help answer any questions that you guys may have. And then it'd be good if we can start second semester topics, even though it's not going to be on the quiz on Monday, just because Tuesday and Wednesday are going to be so short. So, but I may also go over some problems on page 13 and 14 as well. Okay, come get your phones. Well, tomorrow I'm taking pages 5 through 8, but then after that, everything is pretty much next Friday.
Bye. Yeah. I'm excited for the. Oh,